Assalamualaikum warahmatullah. Today's topic is use of exponents to express small numbers in certain dot form. Okay, what does it mean? That the knowledge that we have accrued so far with regard to the exponents. Okay, so how can we apply that knowledge of exponents to express or to convert small numbers in certain dot form? Okay, let's first try to understand what certain dot form means. See, I have taken an example of a number. Okay, it contains as many as 3, 6, 9, 12, 15 digits. Okay, it's the number comprising of 15 digits. Okay, it is, it takes much of your time to put this number on the paper. Okay, it is also very difficult to pronounce it, to read it, right? Okay, so there is a procedure with which you can convert this number in a simple form, what is called as then standard form, right? See how this number can be put in this form as well: 5.72 into 10 raised to power 14. This is it, a certain dot form. Now the point is, how can we convert a number into its standard form, right? Okay, let's take an example in order to understand how how a given number can be transformed into its certain dot form. See, these are some examples. This 149,600,000,000 meter. It is the distance from Earth to Sun. Okay, so anybody asks you what is the distance from Earth to the Sun? Okay, so you have to answer him or her that this distance is this much. Okay, this is the speed of light. Okay, and this is the size of plant cell size. Okay, see, if you try to answer a question like this, what is the distance from Earth to Sun? Okay, so it is very difficult to communicate such numbers. Okay, it is very difficult to communicate such numbers, and also it is very difficult to put such numbers on paper. Difficult to write these numbers. So there must be some procedure, there must be some method, okay, in which these numbers can be transformed in a simple form, so that we can communicate these numbers, we can write these numbers easily, right? Let's see how we can convert these numbers in standard form. See, we know that. Okay, let's take this number. This is 149,600,000,000 meters. All right. Okay. So there are as many as 3, 6, 7, 8 zeros. There are 8 zeros. So we can put it like this. Okay, we know that 1496 into 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this can be put in this form as well. This is very easy. Now again, okay, if we convert this figure into into its exponential form, okay, we will get 1496 into 10 raised to power 1, 2, 3, 4, 5, 6, 7, 8. Okay, number of zeros. Okay, that becomes the power of 10 raised to power 8. Okay, so that means we somehow converted this number in a simple form, but this is not its standard form. It is 1496 into 10 raised to power 8. Okay, so in standard form, okay, there should be the decimal only after the first digit. So that means decimal should be somewhere here, 1.496 into 10 raised to power something. Okay, see now what will I do if I write this number? Say for example, see we were here 1496 into 10 raised to power 8. This is the distance from Earth to Sun. This is the distance between Earth and Sun. Okay, so in order to convert this now further, in order to make it further lucid, okay, in order to convert to standard form, what will I do? See, we know that, okay, what will we do? So if we somehow try to drag the decimal here, okay, so decimal, every number has a decimal at the end. For example, 7, it has got the decimal here, 7.000, so that means it is equal to 7. 86.000. So always the number, the numbers in which there is no decimal, okay, the decimal is at the end, okay, so that the decimal at the end means, okay, so that the number is whole, okay. If the decimal is somewhere, for example here 8.6, this number is not whole, right? Okay, so the number which is not, which does not have the decimal, they have actually the decimal at the end, okay. So here there is a decimal 6.000 in 10 raised to power 3, okay. So we have to drag this decimal here 1.496, okay. So we have to drag this decimal here. So what does that mean by dragging this decimal? We are actually dividing this number. 1496 divided by how many digits are there to reach to drag this decimal to this place. So there are 3 digits. So that means we have to divide this number by 1000. Okay. Then there is 10 raised to power 8. Okay. Okay. If we are dividing, we have to multiply 1000 as well. So the balance is maintained, okay. So that means the final value of this number may not change, okay. So that means we are dividing 1000, okay. So we have to multiply 1000, so that 1000 they will cancel out, the number remains the same. So but we do not have to cancel these numbers, okay. So what we will do, we will divide this number with 1000. I will get 1.496 into 10 raised to power 8, okay. We can convert this number into exponential form, 10 raised to power 3, okay. Then it becomes 1.496 into, these bases are same and there's a multiplication operation, okay. Then these powers are added, so 10 raised to power 8 plus 3 is equal to 11. Okay, this is the standard form of the distance between Earth and Sun, the distance from the Earth to the Sun, okay. So this is how we convert a large number into standard form. Let's take another example. Okay, let's take another example. Okay, we are trying to first convert large numbers into standard form, okay. Then based on that we will also take the examples of small numbers, okay, how we convert the small numbers in their standard form, right? Okay, see, let's take another example. Another example, for example, see this 3 0 0 0 0 0 meter, okay. This is the speed of light, okay, the speed with which light travels. Right, so we have to convert this number into standard form, okay. So this is very easy, okay. See, for example, the decimal is somewhere here at the end of the number, okay. There is nowhere decimal here, okay, but the decimal is always there. So we have to drag the decimal here, okay. So for that we have to divide this number by 1 2 3 4 5 6 7 8, okay. So that means we have to divide this number 300,000, okay. Divide by number by this much, 2 3 4 5 6 7 8. So for example, we have to drag this decimal here. So that means how many digits are there? 1 2 3 4 5 6 7 8. So that means we have to divide this number by this much, right? When we are dividing this number by this much, we have to multiply this number as well. 10 raised to power 8. 1 2 3 4 5 6 7 8, okay. So that means, so that they may cancel each other, so the number remains the same, the final value remains the same. But we do not have to cancel the number, so what we have to do, so we will divide these two, we get 3.0, so that means 3.0 means 3, so we have to try Okay, so when we divide these numbers, okay, zeros and zeros, we get 3 divided by 1, that is equal to 3 into, okay, convert this into exponential power 1 2 3 4 5 6 7 8 10 raised to power 8, okay, meters per second. Okay, so that means this number is converted to start form. Okay, so because the decimal is just after the first digit, okay, 3 point. Okay, so that means here is the point. Okay, it is only the point is only shown when there is another digit, 3.1 2 3. Okay, so it is a single digit. It's not necessary to show the decimal 3 into 10 raised to power 8 meter per second. Okay, now it becomes it becomes very easy to to communicate these numbers, to write these numbers. Okay, when we convert these, when we convert large numbers into their standard form, right? Okay, now here is an important thing that we have to remember, that okay, so this is the long procedure. So what we have to remember, see, this number is converted into its standard form. Okay, so what we are actually doing, okay, when we convert the large numbers into the simple form, we are actually moving, okay, towards left side. Okay, towards left side. Okay, when you are moving the left side, so the power is always the positive, right? 10 raised to power 8. It is not 10 raised to power minus 8. Okay, I will provide you another example. See, this is another example. Okay, so we have to convert it into the standard form. So what we have to do, simply in a simple manner, what we have to do, we have to drag this decimal, the decimal which is somewhere here. Okay, right? We have to drag this decimal just next to the first digit, so here, right? So we are actually we have to drag this towards left side. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Okay, so that means we are dragging the digit towards left side, so it becomes 5 point. So we have to mention these 5.782 into 10 raised to power 15, not minus 15, because we are dragging towards the left side. Okay, same procedure is followed when we convert small numbers into standard form. Okay, I will write down a small number, 0.00001275. Okay, this is a small number. See, this is the small number, the number less than 1. Okay, it is very small number. Okay, so what we have to, in order to convert this this number into standard form, we have to drag this digit from here to the next to the first digit. Okay, first whole digit, right? Okay, so this when we are converting the small numbers into their standard form using exponents, so we are moving the digit to right side. Okay, when you are moving the digits towards the right side, then the power, then the exponent it becomes the negative. So that means, okay, we will see here 1 2 3 4 5, right? So it becomes 1.275 into 10 raised to power minus 5. So okay, when you are dragging the digits towards the right side, the exponent, the power, it becomes negative, right? Okay, so I will take another example from small numbers, right? Okay, see, say for example 0.000001 2. Okay, this is another example. So we have to drag digits towards the right side. Okay, so in this direction, so we have to drag digits somewhere here. Okay, so it becomes 1 2 3 4 5 6. Okay, so the number becomes 1.2 into 10 raised to power minus 6. Okay, so this becomes the standard form, right? So by converting the small numbers or large numbers, very large numbers, okay, which are very difficult to communicate, they are very difficult to pronounce and read, so they must be converted into standard form, right? So this is how we convert large numbers and smaller numbers into their standard form, right? Okay, now inshallah tomorrow we'll be talking about some different topic, probably practical geometry or something. Okay, we'll check that. Okay, this is all about this chapter, exponents and powers. right? Okay, inshallah we will come up with a new topic tomorrow. Till then, peace out.